What is going on, fellow game developers? My name is Muddy Wolf, and in this video we're going to be creating this top-down grapple hook application, game, mechanic, however you want to call it. It's really cool. You can move around, you can take your shot and then get pulled towards an object. The object, you can tag specific objects or you could just let it tag all objects. It's up to you. So what we're going to do is we're going to start a new project and we're going to create all this simple movement, camera script, and also the grapple hook system. So you can create some awesome games. I'm excited to see what you create with this mechanic. So at me on Twitter, Tyler_Potts_ with what you've created, and I'd love to try them out. Or join my Discord server. Link will be in the description and you can post your project there and let me know about it there. So guys, without further ado, let's get started. Okay guys, as you can see here we have a Unity Hub 3.0 beta 0.6. Don't worry if it looks different to yours, it's practically the same stuff. We're just going to create a 2D core element. We're going to name it top down grapple YouTube, and then we're going to create the project, and we're just going to wait a second while this creates our project for us. Okay guys, so that is now loaded. We have a 2D application load up. So what we're going to do is let's go onto the main camera and change this color. It's ugly. We want a 3-2-3-2 and a 3-2, a little dark gray there, so we won't be working with white colors. So we're going to create an empty object and call this camera. Now we're going to drop the main camera inside of this camera, and there we go. That should now be set and ready to go. So we just need that for our movement script. We also need to create a new 2D, and we're just going to create a 2D circle element. So we're going to call this guy player, just like that. And I think he looks good. There we go, all set and ready to go. Look at that beautiful player boy. And then finally, we're just going to create that's an empty game object. I need to create a cube or a not a cube, a square. And then we're just going to call this grapple point. Something like that, whatever you want to name it. But we're going to give this a new layer. So add a new layer and call grappleable. Is that a word? We'll do grappleable. Right there, and then click on this guy and just basically add grappleable. Let's move him off slightly and a bit up just to make it a bit more. Let's give him 5 and 4. There you go. So he's up there. He's quite a distance away. We'll have to grapple to him. And you know, let's change the color of it. Let's make it a reddy color. Let's go for something like not too red, but not, you know, not bad. There you go. That'll do. So there we go. We've got that. Now we need to add a few elements to our player. The first one is going to be a rigid body 2D for our movement. We also need to go to edit, down to project settings, and go to physics 2D, and we're going to set the gravity equal to 0 because we do not want any gravity in our game. We don't need it. It's a top-down game. You don't really need it. We're just going to set our gravity scale on our rigid body to 0, although it probably won't have any effect because we've already set it to 0 in the settings. We're also going to freeze the said rotation. We don't actually need to worry about that. If you do need this, and you can, this is just for our current player controller. And then once we've got all that, the rest of this seems to be good. I'm going to change interpolate to interplay. I'm pretty sure it helps with the camera movement. So there we go. So that's all good. We then need a line renderer. And on this line renderer, we're going to set the positions equal to 0. We're going to set the width to about 0.2. Now you can mess around with this to see what works best for you. We just want a straight line. You know what? Let's give it 2 positions again, just so we can see what this looks like. Let's just say 5 and 4. So it actually hits the other player. We need a material. So if we go down to materials, we can select this and click the default line renderer to actually give us that white line. Now we can change the color. I'm just going to select a fixed color. I'm going to remove these colors and I'm just going to set this to a yellowy color. That's an ugly yellow. Let's go. There we go. Just something like that so we can easily see the thing, and give it the end cap to about 10. Now let's give it 20 so it's perfectly round on those ends. You can see the ends there. We need to actually round them out, and that looks good. I think that's good. Let's reset our positions equal to 0, and what we're going to do is we're going to turn our line renderer completely off because we don't need it just yet. We'll enable it when we actually need it. Once we have the line renderer all set, we then need to actually create our player movement script. So let's just say player movement, hit enter, and create and add a new script. Now that's done, we can double click this and it's going to open it up in Visual Studio Code for me. Now we don't actually, I'm just going to quickly shrink that and up the size of this a little, probably too much. There we go. And we don't need collections and that right now. We don't need any of this. Let's just remove this. There we go. So now we have this blank mono behavior script. Now, the first thing we want to do is get a rigid body. Hello, what are you doing, Copilot? We don't need you. We need a rigid body 2D. We're going to call it RB. And then we're going to get also reference to our serial. Well, we're going to create a serialized field float called speed, which we're going to set to 5F to start with. We can modify this to match our player. Then we're going to need a speed or an MY and an MX. The MY and MX is our input on both the Y and vertical and horizontal axes. We then want to say start RB is equal to get component, and that should be good. We then need to say update, and inside our update function, we're going to say MX is equal to input.getAxes raw horizontal, and MY is equal to input.getAxes raw vertical. So this is going to return values between 0 and 1, and if I press A on my keypad, it should give, -1, so it should give me -1 on the X. If I press D, it should give me +1 on the X. Same with W and S for the MY. Vertical, the angles, raw axes, should I say. And then inside our fixed update, we just need a new thing, and we also want to just say dot normalized, but we want to times speed. We want to get rid of the speed inside of here. We just want to create a new vector 2 to apply our velocity to our rigid body, and there you go. So this may seem, I may have went a bit quick with this, but basically it's super basic. You can add more to this if you want to, but this is how we get our player moving on the Y and X axes. We get inputs from both our horizontal and vertical, and then we apply them for a velocity in our rigid body. So there we go. So now let's go back to our Unity instance, wait for the scripts to assemble, and let's just hit play and see if we can move our player around. So there you go. You can see we're moving around very nicely, but the camera isn't following us. Now, the camera isn't always, you might not want the camera to follow you, but if you do, there's a reason why we put the camera inside a new area, and that's because we want to create a camera follow script. And let's just hit enter. So the reason I pull it inside of main camera is to stop any jitter, because if we move this will follow this and not the player, and it will have a smoother movement. Let's open our camera follow, and now this is a super difficult script. What we want to do is we want to say serialized field. We're going to get a transform, which is going to be our target, which will be normally our player. We're then going to put in late update, not update. We want it in late update because we want it to move after we've actually our player's movement's actually transformed or moved. And then we're just going to do exactly this. Although we don't have to do that, we can just say target dot position there. So we're just setting the camera's position to our target's position in a late update, and there you go. That's all we need to do. Now we can set offsets for this and a bunch of other stuff, but again, this is a super basic camera follow script. So there we go. So let's go back to our area here, wait for it to load. Now let's drag our player in here, hit save, and let's hit play and see what happens. So now if we move around, you can see our player is moving around nice and smooth, and this is also sticking near us as well. Now you can use whatever you want. Obviously, it's up to you how you move your camera. Now in the grapple point, I forgot to add a box collider 2D, so we can actually collide with this, and actually when we shoot a raycast out, we want to be able to hit this box here. So there we go. So we got that on there. Now let's go back to our player. We've got our movement script. Now the final script we need is our grapple hook. So let's create it. So inside of grapple hook, we'll create a new script, and let's just wait for that to load and double click it. Now here we go. Now this is the complex script. So there's a few things we're going to need to do. We need to get reference to our line renderer to start with. We can call it line, LR, whatever you want to call it. We then want to get a serialized field, and this is going to be our layer mask for our grappleable. Is that how you spell it? I think that's how we spell it. So we're just going to stick fit. We're going to pretend grappleable mask. Now we're just going to pretend we're right. We might be wrong, but it's fine. You guys don't have to worry about this. We're going to get a max distance, right? So this is going to be how far we can actually shoot the line. So we can set this something small, so we can only shoot when we're really close, or we can do it quite far, so we can shoot when we're further away. We can then just say serialized field, float, and we can set the grapple speed. Now I'm going to set the grapple speed to 10 for now. We're then going to have another serialized field, which will be not grapple length. That would be interesting, but we're going to have shoot speed. So that's going to be how long it takes our actual grapple to hit the object. We're then going to have a boolean, and it's going to be called is grappling, and it's going to set equal to false. We're then going to have a hide in inspector public bool called retracting. So we're going to be, once we start grappling, we'll say is grappling, but then once we start reeling our player towards the element, we're going to set retracting. So we're going to need to stop our movement while we're moving in, else we could add counter movement, which would be pretty funny, to be fair. Maybe we should try it one time. But here we go. So we'll have an effector 2 called target. So this is going to be the target we find. So if we click our mouse, we're going to shoot a raycast. And if we hit something, we're going to say it as our target. Now we've got all that out the way. Let's go to our start method, and we need to set our line equal to our line renderer component by using get component. Then we need an update method. Inside of our update method, we just want to say if, or if we say input.get mouse button down, and we're going to say 0. So if we click our mouse button, we want to say start grapple. We also want to say and it's not grappling, because we don't want to be grappling while we're trying to shoot around ours. We're going to cause some issues. So let's create this function down here. So we're going to say private void start grapple. And there we go. So now inside of here, we want to get a few things. First, we need to get the direction of where we're shooting our raycast. So we're going to say vector to direction is equal to camera dot screen to world point input.mouse minus the transform dot position. So what we're doing is we're just getting the direction we need to fire our raycast. Now we're actually going to fire our raycast. So we're going to say raycast hit 2D hit, and then we're going to set this to a physics 2D dot raycast transform dot position in the direction we choose, and we're going to set our max distance, which is up here. And finally, we're going to set our grappleable mask, so we only hit those specific items. Now, you can change this to be whatever you want. You don't have to use a mask. You can hit any object you want. But for now, we're just going to set grapple mask, and there we go. Now, under here, we don't want to check if we've actually hit anything. So we're going to say hit.collider is not equal to null. So if we hit something, we've got to do some things. We've got to say is grappling equal to true, because at this point we've hit something. It means we can actually grapple. We don't want to say target is equal to hit point. We don't want to say line dot enabled is equal to true, because we want to start showing our line, and we want to set our line position count, because we only need 2 positions, and we're going to set equal to 2. So basically we're just going to make sure our line has 2 points we can transform, basically. Now we actually need to go up here. We need to start a coroutine, and a coroutine basically allows us to, I'll show you once we get it. It will make sense once we get it. It's hard to explain, you know, there's a lot of things. And a coroutine, you don't need a void, you need an IE numerator, or not numerate, and we're just going to say grapple, and then we can say we need to get a time. So we're going to set the time equal to 0 or t. We're then going to get the actual time it's going to take. So we're going to say you can give any number here. You'll just need to mess with some numbers. I'm going to go with 10. I find it goes pretty well, and we just need 10. We can then set the line dot set position, and we're going to set position 0 equal to our current position. We're also going to say line dot set position and 1 equal to our transform dot position. Now the reason we're doing that is because we want to make sure our line starts at our player. So we're getting the current line, which should always be our player, and then we're going to set our actual line at our player as well. So once we've got that done, we then need to set up a new vector 2, and we'll call it the new position. We'll then say 4 and just colon, because we've already created the variable. We'll say if t is less than time, t is plus equal to grapple shoot speed times time.delta time. Now this is going to give us a nice smooth time. It gives a nice smooth time, and it should always be pretty consistent. We're then going to set the new position equal to vector2 dot lerp, and we're going to say transform dot position, and then target, and then we're going to say t divided by time to give us our actual duration. Now we'll say line dot set position 1 equal to the new position, but we also want to say line dot set position 0, and we're going to set this to our transform dot position. Now the reason I want to do this is because I want to be able to still move while we shoot our line, meaning if our play is still moving, we need to make sure we update this every single time we move the grappling hook. So what we want to do is then say yield return null. Now the reason we return null here, or we yield return null, is because we need to tell this coroutine not to continue the rest of the script until this is finished. And then we can say once we have finished looping through and we have our line has hit the other side, we can say lr dot set position, or sorry, line dot set position. I'm going to set number 1 equal to our target, because we want to basically make sure the target is attacked, and then, or set, so the position is actually set, and then we can say retracting is equal to true. Now once we're actually set to true, inside of our update function, we then want to go if retracting. So once we've got to the end here, we're just going to say, hey, we're now retracting. So we've reached the hit point. So the hit point was obviously what we set the target to. We've actually hit that with the line renderer. Now let's actually set the, let's start reeling in. So we're going to say retracting, and we can say vector2 grapple position. So let's say grapple plus is equal to a new vector2 dot lerp, because we need to get we need basically move our player between 2 points. So we're going to say transform dot position, and there you go, that's actually correct. So transform dot position is where we're starting from, and we need to move him towards our target at a specific speed, and that's going to be our grapple speed. So then we're going to say transform dot position is equal to our new grapple position. We then want to set our line renderer, so our line set position, and we're going to say 0 to our new transform position, because obviously we don't want a line sticking behind us. And then we can finally say, once we hit that new point, we can say vector2 dot distance is transform position target. And if it's less than, let's say 0.5, we will stop retracting. We'll stop grappling. Is grappling is equal to false, and we can set the line dot enabled equal to false as well. So the line no longer appears, and then we should be able to move again. So we actually need to set our movement to stop once we retract, but for now I'm going to show you what happens without it. So let's go back into Unity. So that was quite a long script, the grapple hook, but now we can set our grappleable mask. We also have these to mess around with, so feel free to move these around, change these to what suits your game, and let's actually give this a go. So let's hit play. And now if we move and we shoot, you can see it shoots a line and it pulls us towards the object. So there you go, you can see it's really good, it works really well, and it pulls us towards. Now you can mess around with these settings. So look, one thing you can do is I can still move while I'm shooting my grapple. Now, as in while I'm moving towards it. So I can get some like offset here, and I'm trying to pull back. It's not as bad as I thought it would be, but it's definitely not the best. So to fix that, what we can do is we can go back into our player movement script, and down where we see our velocity, we can say if, first we need to actually get reference to our grapple hook. So we're going to say grapple hook, GH, and when inside of here we can say GH equal to get component grapple hook, which is going to be our grapple hook script. And then in here we can say if grapple hook dot retracting, then we could, or no, we're going to say if we're not retracting, then we can move, else our velocity needs to be 0. So rb dot velocity is equal to 0, or no, vector 2.0, shall I say, because we need a vector with 0, 0 in it. And there we go. So that should now fix that issue, and it should make it a lot quicker. Although it wasn't an issue for this sort of scenario, it could have been an issue for a later game or someone else's game, so I thought I'd just share it anyway. So now you can see once it hits, I can no longer move and change position. It will just drag me straight to position we landed on. You can move while the line is shooting, but you can't move once you're actually being retracted in, which is great. So that is how you create a top-down 2D grapple hook inside of Unity. I hope you've learned something new. If you have, don't forget to leave a thumbs up. If you want to see loads more tutorials, then don't forget to hit that subscribe button, guys. And also, if you're new around here, you can join in with the Discord community. It's down below. We're all pretty friendly bunch of game developers, web developers, programmers in general, and it's pretty fun, so come join us, guys. But for now, guys, thank you for tuning into this video, and peace out.